Okay, so this is the last topic in the course, and we are going to talk about fluids and then pressure and buoyancy. So those are the topics that we're going to discuss. So a fluid is a substance that flow, like gases, liquids, honey, water, uh, smoke. Those are fluids. So gases are compressible. That means you can compress them and they change their volume. Fluids in general, we can think of them as incompressible. It's really, really hard to compress a fluid and change the volume. So a quantity that is important that is going to come to play all the time is density. Density is the mass divided by the volume. The units of density are kilogram divided by meter cubes. And so here is the density of gasoline. And so the density of water is 1,000 kilograms per meter cube. That's a number that is nice to remember. So here are values of density. So you have hydrogen, helium, air at 20 degrees and air at 0 degrees. You see it's more dense as you lower the temperature. Gasoline, alcohol, oil. You see oil is 900 kilograms per meter cube, and then water. This is why oil floats in water. Seawater has salt that makes it a little heavier. Blood is a little heavier than water. Glycerin and mercury. This guy is very heavy. So let's define now pressure. Pressure is a liquid when it is contained, or any fluid in a container, except force. There are forces from that fluid into the walls of the container. Right here we have a force, another force. If we take those forces and divide by the area, then we have what is called the pressure. The pressure is force per unit of area, so the units of force is newtons, the units of area is meter square, so the units of pressure is newtons per meter square, and we give that a name of a Pascal. A Pascal is a tiny unit. We'll talk more about units in a little bit, but normally other units of pressure are PSI and ATMs. So pressure is the same everywhere along these lines, right? So if you measure the pressure is always the same. So so we can measure the pressure. How do we measure the pressure? We can come up with a device like this, and then there's going to be a force here. If we divide this force by this area, we can get the pressure. So the pressure is everywhere. We find the pressure in the fluid everywhere in the fluid. So it's going to be, so if you get this point here, right, and then you rotate this thing here, right, the pressure is going to be the same no matter where this thing is pointing, right, and it is the same along these horizontal lines. So an important equation for pressure is the hydrostatic equation. So we can think of, let's just look at this quickly. So imagine this column of water here, or liquid. So, and it is at equilibrium, so that means all the forces add up to 0. And so there is a force pushing up, there is a force pushing down, and there is a weight. So we get weight plus the force pushing down have to be equal to the force pushing up, right? So then we can, the force pushing up equals to the force pushing down plus the weight. So now if we divide by A, right? So we get that the pressure is equal to the pressure down here is equal to the pressure up here plus rho times G times D. This is distance here, the depth. So that tells you that the pressure increases as you go down. This is the hydrostatic pressure equation, and it's an equation that we're going to be using a lot in this class. Let's look at an example of how to use that equation. Imagine a submarine, and then it is at 300 meters. What is the pressure at that depth? So, and I'm gonna, you're asked to give the answer in Pascal. and also in ATMs. So let's just look at this. So the conversion that we're going to use is that 1 Pascal, 1 ATM, right? 1 ATM is equal to 101,000 Pascal, right? So that's a lot of Pascals, but that's because Pascal is a very tiny unit. So the density of seawater is 1030 kilograms per meter cube. So now we use the hydrostatic equation, and we're going to solve this in Pascal first, right? So the pressure that we want is equal to the pressure at sea. So this is the sea here. This is a submarine, right? This is D, which is 300 meters. So here we have a pressure P0, which is 1 atm. And this is the pressure we want at that point P there, right? So that pressure P is equal to 1 atm, which is P0, plus the weight of the column of water on top of the submarine, right? So that is rho GD. So then we put here 1 atm in Pascal, density of seawater, G, and 300 meters, which is the depth. And then we get this is 3.13 times to the 6 Pascal. So that's roughly 30 atms. It's 30 times the atmospheric pressure. So that's a really, really huge pressure. So like I said before, so these points here, these lines, they all have the same pressure in liquid. So that's a trick that we can use to solve problems and to create neat devices. So imagine that you want to find the pressure here, right? So, well, if you look at this line, so the pressure here is equal to the pressure here. So all you need to do is find the pressure here, and you know the pressure here, this is 40, this is 100 centimeters. So how do we do that? Well, we know the pressure here, that is 1 atm, which is 101,000 Pascal, right? So this distance here is 60, right? So all you need to do is P is equal to P0, which is 1 atm, plus rho, which is the density of the liquid, times G times D, which is 60 degrees. So this is that equation. So then you have 1 atm, density of water, G, and 60, and then you get that the pressure here is 1.061 atm, so a little higher than 1 atm. So how do we measure pressure? Well, to measure the pressure, we use a few devices. So let's just look here. My apologies. Let's just look here at how to solve problems. So remember, first draw a picture, and then so find a surface that is open. That'll be at 1 atm. Then just contact and then find all these horizontal lines. And then so if the surface is in contact with a gas, and I'll show you one example, then they'll be at the same pressure. And then a closed surface would have a force divided by the area. Horizontal lines, this is where I was going to, a horizontal line, then you can write those horizontal lines, and the pressure here is the same as here. And then there is this idea of gauge pressure. Gauge pressure is the pressure that you get relative to 1 atm, the atmospheric pressure. So that is the pressure that you normally measure when you measure pressure in a normal setup. The devices that we use to measure pressure, they measure this pressure here, which is called the gauge pressure, and not the absolute pressure. And then you use the absolute equation to solve problems. So let's look at one example, right? So we have this U-shape device. This is water here. And then you have another liquid here. So you have water fills the side of the tube that include the closed end, and then this is oil. and then they don't mix. And then so we want to find the large pressure at the close end. We want to find this pressure here. So if we trace a horizontal line, this pressure is this. So we need to find that pressure there, but we cannot just do that. We need to take into account a few things. So let's just look at how to do that problem. So this distance here is 75 centimeters. This distance here is 25 centimeters. Right, so for this, we're going to use the density of water, and for this, we're going to use the density of oil. So these points have the same pressure, and this point have the same pressure. So we are given density of water and density of oil. You can get that from the book. Right, so then we can find P1. P1, the pressure here, right, is equal to, well, you use a hydrostatic equation applied to oil, rho 0 times G times H. So that is P1, 1 atm plus 6620. Notice this is your gauge pressure, and this whole thing is your absolute pressure. Okay, so now I have the pressure here, which is P2. So now P2, right? That is P3, apply the hydrostatic equation again. P2 is equal to P3 plus the density of water times G times D, but this D now is this one here, right? So then you get P3 plus this extra here, right? And now we can solve for P3 because we know what P2 is, right? So P2 we solved in the previous equation. We can put P2 here and solve, and we get P3 is this value here. So as I said, 1 atm is the pressure right here. It's the pressure of the weight of all the air on top of you. That's a huge pressure. So we normally call that 1 atm, and is equal to 101,000 Pascal. So these are units. So that's one detail that we need to remember. How do we measure that pressure? Well, one device that we can use is a barometer, right? And here's a nice trick to do that. So imagine that you have this tube filled with water. So now you close it here, and then you put it right there in this situation. So the water is going to come down due to gravity, and there's not going to be air or anything here. So the pressure here is 0. And then we apply and also the pressure here is the same because this is a horizontal line, right? So basically, if you find the pressure at 2, you find the pressure at 1, and this is your atmospheric pressure. And that pressure at 2 is the pressure here, which is 0, plus rho GH. So all you need to do is measure this H, and then you can find the atmospheric pressure, and this is how a barometer works.